Simple calorimeter. Okay, we will use simple calorimeter to measure the heat of neutralization. Okay, and then one more thing that you need to remember, that is heat of neutralization is the heat involved when 1 mole of water is formed from the reaction of an acid and base under standard conditions. Now let's look at the comparison of two questions here. Okay, it is given sodium hydroxide and hydrochloric acid. Okay, and then temperature is given. Okay, then asks us to calculate the standard heat of neutralization, enthalpy of neutralization. Okay, and then let's look at what is the information given here. Okay, first you are given molarity and volume. Okay, but you can see that the molarity is the same, but the volume is different. Okay, so meaning that we will have different number of mole. Okay, so when we have different number of mole, what does it mean? We know that sodium hydroxide and hydrochloric acid, the ratio is 1 mole and 1 mole, but now we have different number of mole, meaning that there will be a limiting reactant. So in this type of question, okay, remember for neutralization, you need to make sure whether is there any limiting reactant or not. Okay, so for this type of question, the first mark will be given for always given for equation. Okay, the reaction equation. Okay, then another one is, okay, given for finding the mass of water. Okay, usually the students having problem to find the mass of water because it's not provided in the question. But just remember, the water means when will the water form? Means when base and acid react. So you just add both volume only. Okay, add the volume of acid and volume of base. Then you will get your mass of water. Okay, using density. Okay, another one. Okay, in the question, there is no heat capacity given, no capital C. There's only small c. Okay, so if there's only small c, and remember when I said once we have water, we can straight away write down mc delta T. Okay, and then substitution. Okay, and remember again, same thing, the heat release is not referring to 1 mole, but heat of neutralization refer to 1 mole of water, not acid or base. Okay, therefore we need to find the limiting reactant. Only then we will know the number of mole of water produced. Okay, we find the number of mole of limiting reactant, and then we will also get the number of water produced. Okay, and then you do the stoichiometry. Remember to use H2O. Then you get your answer. And remember, because this is heat of neutralization, heat is released negative, and the unit must be kilojoule per mole. Okay, then there's another question here. Okay, same thing again. Okay, it's given that 100 ml of 0.5 molar of HCl is mixed with 100 ml of 0.5 molar of sodium hydroxide. Okay, and this time you can see the number of mole of base and acid is the same. So if they are the same, there is no limiting reactant. So the number of mole of water the ratio you can compare with either base or acid. It will be the same. Okay, now why do I want to compare these two questions? Okay, because in this question, example number 1, the calorimeter, it only has MC delta T. Okay, heat absorbed by water only. But in another question, okay, as we know, we said that the polystyrene does not absorb any heat. Okay, but you have to look at the question also. It does not mean all the time the simple calorimeter is using polystyrene. You have to look at the question. Okay, this time the question said the calorimeter has a heat capacity. Okay, when it mentioned that it has a heat capacity, meaning that this is the capital C. Okay, when capital C means you must also add in C delta T. Okay, so because it produces water, it must have MC delta T. So this time it has two. Okay, absorbed by water and absorbed by calorimeter. Okay, the rest of the step is the same. Okay, then I just want to highlight one thing. Okay, for heat of neutralization, the value should be around 57.3. Okay, it should be around negative 57.3 kilojoule per mole. Okay, so you see our answer 56.7, 56.2. So it won't be far or very different from 57.3. So that is also one way that you can check whether your answer is correct or not. Okay, now summary for calorimeter. When you read the question for calorimeter, okay, you have to determine you will be using two types, okay, either the Bohm calorimeter or simple calorimeter. Okay, but no matter which one you use, you must know which formula to calculate. Okay, so this one, once you see water, once you see the word heat capacity, then you use this formula. Okay, this one is only has heat capacity, this one only has water. Okay, then this part we seldom use it. Okay, this part we seldom use it. Okay, then another one you have to know, is it combustion or is it neutralization? If it's combustion, it means 1 mole of substance, the heat released by 1 mole of substance. Then, but if it is neutralization, you have to be very careful. Your stoichiometry must refer to 1 mole of water. You cannot refer to any substance like acid or base. And don't forget about unit. Okay, now points to remember. Okay, these are the formula that I have mentioned just now. If you have water and heat capacity, water only heat capacity. And then one more thing is, if they give you volume of water, you can find the mass of water because using density. Okay, and then another one, when you calculate Q equals to MC delta T or whatsoever, it does not refer to the heat released by 1 mole of substance. Okay, if you already given the enthalpy of combustion, okay, so, and then the unit must be kilojoule per mole, it means that 1 mole of substance release 100 kilojoule here. Okay, so it means that you will be using this information to help you to solve other problem. Okay, same thing, if let's say you are given enthalpy of neutralization, that means that 1 mole of water, it is not referring to 1 mole of acid or 1 mole of base release 57.3 kilojoule of heat. Okay, then remember the unit for neutralization or combustion must be negative and must be kilojoule per mole. Okay, and then for neutralization, remember to check, is there any limiting reactant or not? Okay, because if there's limiting reactant, the number of mole of water will depend on the limiting reactant. And don't forget to balance the equation between acid and base. And the common mistake that students do is they didn't add up volume of acid and base for volume of water. So that's all for this part.